Please.
Just give me 1 second. So welcome everyone to this ATAL FDP on AI innovations in healthcare and medical technology. It's being organized by SR University, particularly Professor J. Ravichandar from Electronics and Communications Engineering Department, and me, I'm Rakesh Sengupta. I'm the director of Center for Creative Cognition at SR University. I welcome all the participants, including our Honorable Registrar, Dr. Archana Reddy, Head of the Department of Electronics and Communications Engineering Department, Dr. Sandeep, and Dean of School of Engineering, Dr. Leo Joseph, and Dean of School of Science and Humanities, Dr. Raj Shekhar. And also our another person who is where we are very lucky to have is Professor Chinmay Chakraborty, who is also a resource person for our FDP. So I'll first request Dr. Ravichandar to give the opening address.
Good evening all. Respected Registrar Madam, Professor Archana Reddy Garu, Dean School of Engineering, Dr. Leo Joseph, Head of the Department, Sandeep Bhattacharya Garu, and Dr. P.V. Rajshekhar, Dean School of Sciences, and today's our guest as well as keynote speaker, Dr. Chinmay Chakraborty from BIT MESRA, various school deans, heads, and esteemed participants and distinguished guests. Welcome you for the ATAL FDP, AI Innovations in Healthcare and Medical Technology. A very good evening. It gives me immense pleasure to welcome you all to this faculty development program, AI Innovations in Healthcare and Medical Technology, which is scheduled from 9th December 2024 to 14th December 2024. I am Dr. J. Ravichandar, Professor of EC Department, as well as coordinator of this faculty development program. This FDP is a significant step in fostering interdisciplinary knowledge, innovation, and application of artificial intelligence in the field of healthcare and medical technology. First and foremost, I'm happy to announce that we have received an overwhelming response with 117 participants registered from across India, representing various states and institutes. Within a short span of time, within a 1 week, we achieved this number of participants. So this demonstrates the growing of interest and requirement in the field of AI to address critical challenges in healthcare. During this program, we will delve into a range of topics which are transformative potential of AI healthcare. Our sessions will cover introduction to AI in healthcare and medical technology, AI in medical imaging and diagnostics, EEG signal analysis using AI for neurological disorder, cardiovascular health, AI in predictive analytics for healthcare, AI in wearable health device for real-time monitoring, natural language processing in healthcare, AI for mental health, EEG-based cognitive and emotional analysis, AI for ECG data interpretation in remote cardiac monitoring, telemedicine and remote patient monitoring using AI, AI-powered drug discovery and development, AI for personalized medicine and genomics, ethical and regulatory challenges in AI-driven health.
Hello, Ravi. I can't hear anything. Are you speaking? Ravi, you are not audible. Your voice cut off suddenly.
Okay, because now, sorry for the disturbance. Okay, this FDP is not just about acquiring knowledge, it is also sharing of ideas as well as innovating solutions. I encourage all the participants to actively engage in asking questions and make the most use of this opportunity. I would like to extend my heartfelt thanks to AICTE for granting this funding. And I would also thank to our management and our Honorable Vice Chancellor, our Registrar, Deans, and heads of the department and faculty members for their guidance and support in organizing this FDP. My gratitude also goes out to our participants whose enthusiasm made this event truly meaningful. Thank you very much.
Now I would request Professor Leo Joseph, Dean School of Engineering, to give us a few words. Dr. Leo Joseph. Hello, Dr. Leo Joseph.
Leo.
Oh, he has not been unmuted. Mr. Balakrishna, please unmute.
Make him the
Dr.
co-host,
Leo Joseph.
then he'll be able to speak.
Yes.
Okay, good evening all. So, sorry for the delay. So, very good evening all the participants and my greetings to all the organizers, Dr. J. Ravichandar and the co-coordinator for Dr. Rakesh and Gupta for organizing this ATAL FDP. Especially this domain AI in medical healthcare is now a boom. So especially where we have to use AI, that is the meaning, that is the big question to this world. Everyone are studying AI, Python, everything we are learning, but where to use that AI, what is the deployment techniques, how to realize AI in an effective world, that is the real scenario now expected. That is, we want where to use this algorithms and other things developed by computer engineers or data scientists, how to use it effectively. That is the real thirst now we want. So this world now requires deployment experts who can use AI as a better collaborative partners. So instead of thinking AI as a headache, we can think AI as a collaborative partners to improve ourselves. In that, I sincerely, my sincere thanks to all the organizers for choosing this topic, which is the essence of the today AI world. So I encourage all the participants to come forward and learn effectively and make use of these potentials in your research domain and upgrade yourself. In this aspect, my sincere wishes and greetings to all the organizers, Dr. Ravichandar and Dr. Rakesh and Gupta, to move forward ahead and organize this workshop in a effective, in a meaningful manner. Wish you all the best for all the participants. Also, I extend my greetings and appreciations to my sincere thanks to our management personals, Dr. Archana Reddy and our Dr. Deepak Garg, Vice Chancellor, for extending their support in organizing this workshop in a great extent. Wish you all the best. Thank you.
Thank you, Dr. Leah Joseph, for your talk. We now request if Dr. Rajshekhar, are you here? Dr. Rajshekhar? I see Rajshekhar. Maybe he's not here. Okay. Okay, so we'll move on to Dr. Now we invite our Honorable Registrar, Professor Archana Reddy, to give us a few words to begin our FDP.
Good evening, everyone. Am I audible?
Yes, ma'am.
Yes, ma'am.
So I first of all the dignitaries present here, and Dr. Chinmay, a very good evening to one and all. I first congratulate all the convener, Dr. Ravichandar and Dr. Rakesh Singh Gupta for choosing such a nice topic. And my earlier speakers have said a lot about AI in healthcare. Yeah, we all know this is a booming topic these days. And I think the response which they have got is really good, 170 plus participants. So I wish this 1 week FDP is really eye-opening to many people to open up avenues for your research. So I wish that all the participants really interact with the resource persons and make the best use of it. Thank you.
Thank you, Dr. Archana, for your kind words. Now, yes, Dr. Ravi.
Professor Chinmay, invite.
Yeah. Now I invite Professor Chinmay, who is also our keynote speaker, to give us his address. Professor Chinmay Chakraborty is from Birla Institute of Technology, Misra. He is also from Electronics and Communications Engineering Department. Thank you. Please go.
Good evening, sir. Is it audible?
Yes, it's audible.
Thank you. Audible, sir.
Sir, is it audible?
Audible, sir.
Yes, it's audible.
Some bandwidth issues still there. Actually, in Jharkhand, the weather is very bad today.
Yes.
So, very good evening, means all of my respected dear professors, and it's a great honor for inviting me and such a prestigious faculty development program and AICT based. And I am very much congratulate to the coordinator and co-coordinator specifically for getting this kind of opportunity from Government of India. And this is a big privilege for me because of that to give you this such a prestigious means one of the good institute in India. So I am very much honored. And Dr. Ravi Chandar and Dr. Sengupta sir is there, and HOD Madam, Professor Archana Reddy, and all of my respected teachers. And first and last, specifically for participants, that is those are the oxygen, and this has become the pillar of the country, and we are just a barrier. So that's why, as a barrier, I don't know that I'm the suitable or not, but whatever is possible means we will discuss. So I believe this is the interactive session. And artificial intelligence, we know in nowadays, it plays a big role. And this is the emerging area for the present and upcoming researchers. Because of that, we have to take the proper decision-making systems, when we are processing the data from source to destination end. So in the somehow that is in this term, basically all of you mostly aware. So domain specific, we have to find out and what is the gap, research gap, and how to do some kind of innovative works, not only publication, that is for your means top level works like your patent, project funding, and etc. So today means I'm going to present screen is okay. I think so.
Sir, before that, our HOD sir will address some few points. After that, your session will start, sir. Thank you.
Okay.
Rakesh.
Yeah,
Rakesh?
now I invite Professor Sindhi
Department.
Bhattacharya, our head of the department from Electronics and Communications Engineering, to say a few words to begin the session. Professor
Hello, sir.
Sandeep? Professor Sandeep, are you there? Professor Sandeep, I think, is not there right now.
Okay.
I think he was still on the bus going home.
Okay.
So I think we can start, I think, right?
1 minute. 1 minute. Wait. Wait, sir.
Okay.
Rakesh, he is not available. So we can go forward with the session.
So again, we invite Professor Chinmay Chakraborty to give his lecture on introduction to AI in healthcare and medical technology. I hope all the participants can hear and enjoy the session thoroughly.
Is it visible? The full screen mode?
Yes,
Yes,
full screen mode is not visible. We can see the PowerPoint window. Full screen is not visible, I think.
Full screen not visible?
Full screen is not visible. We can see the PowerPoint window.
No. then
Rajshekhar sir also there. Rajshekhar sir?
sir, is it okay?
Screen not visible, sir.
The screen is sharing, but it's not visible yet.
PPT.
It says
PPT
that
not.
you're sharing the screen.
Now it's okay?
Yes, sir. Okay, now fine.
Now it's okay? Full screen?
Okay, sir.
So, very good evening, all of you. The topic means this is the introduction to artificial intelligence in healthcare and medical technology. So, artificial intelligence plays a big role in the present scenario. In the areas of healthcare and industry perspective also. So that's why nowadays you know that is a health 4.0 and beyond, industry 4.0 and beyond. Everywhere AI
Sir, can you turn on the video, sir, for 5
giving
minutes?
there the tremendous role.
Video turn on, sir. 5 minutes, just for 5 minutes. Okay. Okay, thank you.
So in that case, that is a today we will discuss the definitions of artificial intelligence in healthcare sector and what are the recent works and challenges that are involved for developing AI-based medical technologies, and some case studies we will discuss as well as applications and will be highlighted according to the lecture. And this is some of the AI and IOMT and health related books means I have published, and currently I'm actively involved in various IEEE transactions and others also. So that's why for most of the time I am occupied with the means editorial works, and as well as a deputy EIC in IEEE transactions in consumer electronics and in other biomedical engineering and your transaction industrial informatics. Everywhere I have seen that is a what kind of works nowadays researchers are focusing and they are providing the very good outcome. So before going to discuss, that is for Gardner chart. Gardner chart, in that case, two parameters. One is your expectations, another one is the time. So, that is we have started our journey from 1936 onwards. 1936-37, this is the time for the telephony and telegraphy systems. After that, we have started our journey through the various technologies came into the picture. And recent works basically for artificial intelligence. So that's why for autonomic systems and quantum AI, some embedded AI, and neuromorphic computing system also, but neurosymbolic AI, composite AI, and AI engineering, edge AI. So that's why time is a big factor, and as well as the expectation of the populations. So that's why computer vision nowadays plays a big role. So last few years, I think in 2021, in that time that is we worked means augmented AR and VR and mixed reality system for spinal imaging landscape. That is basically for the AI, and with means one of the Amsterdam research lab in Hyderabad. So in that time also we have learned so many things. So that's why Gardner chart plays a big role, and this is the latest chart. If you do something on artificial intelligence, first you need to find out what is the recent trends from the Gardner chart. AI definitions point of view, that means it's a computer and computer-enabled robotic systems that process information and produce the outcomes, and it takes some sort of based on some sort of decision. Actually, three type of modes are there. Later I will discuss. One is your data acquisition. Number two, data processing and communication. And number three, data analytics and visualization. So each and every sector, AI plays a big role in terms of proper decision-making systems. And it consists of parameters like learns from the experience and uses the learning to reason, recognizes the images, solves complex program, understands the language and others, and creates the perspectives. So these are the basic features for the artificial intelligence. And medical AI primarily concerned with the construction of AI programs and that perform diagnosis and make therapy recommendation. Like a different type of therapies are there, and that is nowadays that is robotic therapy is also means getting a good response. So that's why, as far Dr. Castle explains, the AI is not a technology. It's a technique for understanding people and making machines act the way people do. So that's why we are applying that is AI for healthcare and medical technology, but AI is not a technology. So every day I am saying that is a proper decision-making system is required from source to destination end when we are processing the data. It plays a big role in different sectors like management information system, data streams, and data mining, neural net, machine learning, and case-based reasoning, data visualization, telerobotic, telemedicine, and telehealth. So many things are there. Our objective, what are the objectives? To analyze the use of the AI systems as decision support mechanism for critical care. That is a healthcare means that is a most emerging by emergent sectors, and we can process the data in that is a two modes like your real-time data processing types of communication means one is real-time data processing, and number two is the stored and forward approach. Two approaches are there, and to find out the level of the acceptance of the AI systems by the health professionals and to improve the patient communication. So proper understanding is required between doctor and patients. And patient means your service holders, stakeholders. So later we will discuss when we will discuss some sort of the WBAN concept, and and that time you see that is how to improve the patient communication, how to satisfy the patients, how to process the data with minimal cost. So in that case, that is a telemedicine, telehealth, telecare systems, or as well as you can say that is a teletrauma. This is the another area. So to enhance the capacity to process and store a large amount of data in an intelligent manner, means you are sending the patient-centric data. Okay, so that means the huge data, and each and every data, each and every features are very much important. So you need to preserve the data. So in that case, proper means your security mechanisms are required, systems are required, and as well as how to maintain the big data, how to maintain the big medical data, how to maintain, how to handle the large volume of data, okay, in a intelligent manner. So in that case, that is AI plays a big role. You see that is from 2020 visions, and that from there that is a target 2036. So that's where software solution and hardware and services in the help of the AI. So that's why this is a massive data. Okay. And this is the data growth for 2010. In that time, that is we have seen that is a 1.2 gigabytes per year. In 2020, 35. Now is around 57.9 gigabytes per year. This is the data stream. So data volume is the big factor. And you know that is in in 2036. This is the time for the purely the data analytics. So that's the importance of AI in that case in different sectors, and all of you are aware regarding this the issues. So healthcare would be the easier and the quicker for more people to access. So how to increase the accessibility at the end, and how to get the faster response from the doctor and nursing home also. So that's why AI can make the diagnosis faster and more accurately. And advanced computers, robots, in the help of the artificial intelligence, will make the better treatment recommendations. And on the other end, that is like having your own healthcare specialist there. So that's why nowadays people all means we are using smartphone, tablet, and computers. So that's why smart things. So that's why the one, and later we'll discuss that is what do you mean by smart, intelligent, smart. These are the very common term, but having a very important meaning. The trends basically for means your automation of the scientific discovery and routine intellectual means work can be increasingly be done, and as well as that is how to maintain the patient-centric data, how to maintain the electronic health records, how to maintain the medical health records, how to maintain the personal health record (PHR), using mHealth and eHealth system, mobile health and your means electronic healthcare systems. So that's why in that case that is you need to play with means a large volume of data, large volume of health data. Each and every features are very much important. If during the transmission of the data, if you lose any data, so that's why that is your systems can predict means in a proper way. So that's why enabling the faster, cheaper, and lower power and larger scale, more ambiguous and more flexible and data-driven information systems are required. So that's why this is the evidence-based system where X suppose include medicine, policy making, and development aid, and ultimately all important societal decisions you need to take. So that's why each and every sector, and as a population, as a patients, suppose the population in the rural area, our objective is that is how to improve the rural area, rural person with the minimal cost. The cost function is also associated. So, and cost function means that is that is how to calculate by how to measure the cost function. And simply that is in that case that is in Manhattan by your Euclidean distance you can measure. And after the different kind of the optimization techniques are there, suppose the stochastic modeling, the Markov decision theory, MDP is there. So many optimization techniques are there, and as well as your AI, So that's why each and in the help of this kind of mechanism, this kind of algorithms, this kind of technology, your objective is that how to minimize the means your patient centric means your accessibility accessories, you can say low cost. So AI health is a collection of the multiple technologies enabling machines to sense, comprehend, and act and learn, and they can perform the administrative and the clinical health functions. So the increased interoperability between the system, end users, and EMR vendors. So it consists of different means application like image recognition, interpretation, diagnostics, and assistance and generating reminders and alert and therapy planning. The benefit means that is a fast and accurate diagnosis, and how to reduce the human errors. And definitely you need to minimize the human errors if some errors are there. So that's why these are the big problem. Another error, that is for your data communication. In that time you have already means error like your different kind of error correction code, different kind of means error detection mechanisms are there. If you're finding any error, and then you means your system will ask, suppose you know that is in two modes. One is your source, another one is the destination. First, source need to send the request message. Say, okay, we will send some kind of data to the server. After receiving the request commands from the source, after that they generate the green signal like acknowledgement. And after getting the acknowledgement message by the source, and then they sending the data. If you are getting the negative, means your red negative acknowledgement, please resend the request message again. After getting the green signal like acknowledgement, after that you can process the data. So another point is that in the means for choosing the artificial intelligence, because of the cost reduction is the one of the factor. Another one is the means the virtual presence and telemedicines. And these are the top application like your different value wise means I have taken this one from the Essentials analysis like in the robotic assisted surgery and virtual nursing, administrative workflow, and fraud detection, and also error reductions. So these are the features that is where the means application and values are involved. And this is basically for means US clinicians, they mostly follow that is your supply chain point of view. That is for a green medical system, how to set up the green medical systems in the help of the without proper decision making systems, you can't think about the green. Like that in 2020 vision it says that is a green technology. So that's why in this concept basically means this is the green medical systems, like a proper decision making is required. So as well as supply and demand, you need to balance it. So that's why that is a 20% estimated that is unmet demand addressable via the artificial intelligence as per the Accenture analysis. So this is the focus area of different organization in the, means that is in hospitality and specifically for health plans, and means your patient care and data science and your cyber security. So that's why we'll discuss some little bit of the secured system, speech recognition, and NLP. And in that case, that is AI just see the history like the significant milestone, and that reflect the evolution of technology. Its application in medicines decades. So 1950s, that the AI concept inception is there. The 1960 to 17 is 10 years. This is the initial explanatory, the applications in the healthcare. After that, is early means two case that you overcome the limitation with the deep learning advancement, and foundation modeling came into the picture in that time. And mid 20s, this is the advancement of the diagnosis, and you see that is a means after 2010 onwards, you see that is a means you're in the help of the AI-based technologies, AI-based mechanisms helps us for getting the better treatment, better diagnosis facilities. And late 2000 and 2010, that is in this period, the integration model is also there. Integration. You need to integrate among the different sectors that related to the healthcare with the help of the clinical decision support system CDSs and your predictive analysis. Predictive analysis is required because of that. Based on your predictive analysis, based on the prediction, you can predict Based on the data set, you can predict. So that's why these two parameters are plays the important role here. And later, that is the key areas, means your 2020s onwards, you see that is some few 4 points are there, for 5 points are there. Like one is the early detection and diagnosis, and these advancement that is facilitate earlier detection of the disease such as cancer, and means now means I will highlight means your in your today's lecture, like your colonoscopic images, like your cancer type. So potentially improving the patient outcomes. This is our objective. And precision medicine and AI role in the precision medicine has grown and assisting in the customizing the patient care. And another one is the robotic surgery. And today means I'm not going to details for the robotic surgery because of it having a very large data set, and means 2017 and 18, these 2 years I worked on robotic surgeries also. This is some prosthetic concept is also we have incorporated and published on one of the papers. And patient management, this is the important issues, and how to manage the data, how to manage the patient-centric information, patient-centric clinical information in the help of the AI in a real-time basis. This is the one of the important area, as well as your drug development. So machine learning models, this is the subset of the artificial intelligence. It have the accelerated drug discovery processes by predicting the molecular efficacy. So this is the graphical architecture. Here you see that is in healthcare AI timeline. Yeah, that is where we have started in 1956 that we have already discussed. And this is the first coined by the Minnesota Dartmouth College, that is AI term in that time. And after that, through 1972, using means via the mycene. And after that, even 1979 and 1986, in that time, that is you explain the diagnosis and based on the CDSS systems that we have discussed. After the 2010, in that time, that is a computer-aided diagnosis system in the endoscopy came into the picture. After the 2017, the first that is FDA approved cloud-based concept. And you know that is previously we are means we are sending the data from source to server, and nowadays we are sending the data source to your cloud computing. Okay, cloud, you know that is a cloud computing system, your edge computing. So that's why these are the features are there, that is how to preserve the data, how to process the data in a superior way. So this is the means your picture. I am not going to details. And 2022, in that time, that is your introduction of the TREWS. That means it's a targeted real-time early warning systems for means your sepsis detections. So that's why this is the era of artificial intelligence in modern healthcare sector. And these are the various applications. So AI, this is the latest AI application, AI in the diagnosis systems and AI in the medical imaging, AI in the pharmaceutical and the new drug development, and AI in the hospital information system, HIS, you know, and AI in the medical research, AI in wearable system, where is the clinical grade applications are involved. AI to build the virtual assistants. So I told you that is one of the paper like AR, VR, and mixed reality nowadays plays a big role in the help of the AI mechanism. AI nutrition. So nowadays people are thinking for the obesity and this kind of works and dieting obesity in this manner, that is nutrition. They are predicting some things related to, based on the AI, and AI treatment for the mental health. Okay, so early detections, early identification of the mental health symptoms. This is the one of the major area. And AI emerging room and surgery, like robotic surgery, informed you. So that means this is the in general, means your industry, research area, and different funding agency also. So in that case, your AI in healthcare basically for the telemedicine, telehealth, means your disease management, AI chatbots, and wearable device. So in this slide, basically for in general concept. Okay, so that's why that is a as a technologist that is we can see that is where is the means not only in the one particular sector, in every sector, in every each and every stage, yes, each and every node. So in that case, that is AI plays a big role. So that's why nowadays cost can be minimized. We can take the proper decision making system. We can get better patient-centric outcomes from the top level nursing home or your doctors also. Not only from India to India, we can get the better response from the abroad also. So suppose one patient from here in India suffering some problem, so that's why you can easily get the better treatment modalities from the USA or any other countries. And you know that is I told you before, like one term that is intelligent and smart. So that's the intelligent and smart that is nowadays that is in Internet of Things. This is the one of the important area. Like things means this is the objects. Internet means that is we are processing the data. Storage unit, cloud. So that's why that means we are extracting the data. Suppose you can consider the WWAN, wireless body area sensor networks. So in body, that is, you assume that is several number of sensors are there, several number of objects are there, several number of things are there. We are acquiring the data from the things, from the objects, or from the nodes. And at the coordinator end, accumulate the data and processing the data. So that's why this is another technology, but this is directly correlated to the AI systems. And we have started our journey from 1990s. It is the first point by Kevin Est, and the IoT initially promoted, that is in the help of the RFID technology. After that, till 2010 this is not accelerate in a good way. After that, Gardner Chadin came into the picture, and after that, in 2014, reached the mass market in the real scenario. And 19, that is the 5G network is already established. And another thing, Industry 4.0, AR/PR system, autonomous car, AI, ML, and IoT. So each and every case, you need to take the proper action for processing the data. So AI technology and machine learning have evolved, influenced how healthcare delivered profoundly in different sectors like your radiology, screening, and psychiatry, primary care, your disease diagnosis and telemedicine systems. And looking into the future, like according to the World Economic Forum, you see that is a future of the AI in healthcare will dramatically change between now and 2030 in the following 3 ways. Like one is the connected care, patient-centric data, how to set up the connected care. So coordination, you need to set up the good coordination. Suppose in any organization, in top to bottom doctors to patient. If we establish in the help of your proper technologies, but suitable technologies, and we can establish the good coordination, or you can establish the good communication, or we can establish some better understanding between individuals to upload, root to leaves. So in that case, you can easily minimize the different kind of rawness of the data. So that's why the connected care is highly recommended in future. And better AI powered predictive care, this is another area from 2024 to 2030. These are the main area, and how to improve the patient and staff experiences. So that's why the trained person is required each and every sector in healthcare. Telemedicine means we know that we utilize medicine, medical patient-centric information we can process through the proper communication systems. And if you consider the ICT, information and communication technology, like a telehealth and telecare system is there, and teletrauma, in that case, that is a ambulance. Suppose one injured person is there, and they are injured happened and at the road. So that's why patient take care in your ambulance. So doctor can prescribe, and based on the prescribed, that is before coming to the hospital or nursing home, so treatment can be treating at a better way. So in that case, that is a trauma, but telecare plays a big role in that case. In the telemedicine systems, and you see that is in the last 2013, and that time actually specifically I'm the expert in the telemedicine, and 2012 to 2016 onwards. In that time, I worked and fully for the telemedicine systems. So that's why in that case, we know, and the different areas like a home means home care and disease management means your test management and your patient surveillance means your disease surveillance center in the program tracking, remote consultation in the critical care monitoring, and second opinion in the complex interpretations. So that's why each and every sector telemedicine plays a big role. So that's why telemedicine means that without AI this is not possible. I told you. So that's why your bandwidth requirement is there. So many sectors are required, but in the help of the AI, you need to take the proper decision-making systems. And these are the like one of the features you see in this diagram. That is here. That is two lines are there. One is the lease line. Another one is your main part. That is from source to destination. This is the coordination. Like if any patient is there, suppose either Bhavanagar, Baroda, in that case, that is a doctor in here in the Guwahati. So easily they can getting the better treatment modalities through the means your AI empowered telemedicine systems. Security in general, that is a for communication point of view, that is a communication point of view, how to preserve the data. So that's why in general, we know that is a trust, identity and privacy, protection and safety and security. These are the major issues. We need to protect the data. So that's why means your general cryptographic means your security system in that time, that is a one is the suppose we are sending suppose a plain text and then your CDS generated KDC generates some random bits. So that's why we are generating the plain text to cipher text. After that, we can extracting the data. So that's how we have started our journey from the means your cryptography, cryptology, analysis. After that, that is now steganography, and nowadays people are thinking we're working on the blockchain and cyber physical systems also. For because of that, that is how to protect the data. Because of the patient-centric data, means some proper protection is required. So healthcare devices are medical technology. Healthcare devices are there. You're dealing them in the primary means private information. So first of all, you need to preserve the means your private informations. How to preserve the patient-centric informations. Okay, so this information needs to be protected from being revealed and modified in power. So critical to identify the analyze distinct features in IoT security, and so IoT is involved in that case. So recently we worked and with from blockchain-based federated learning techniques from the privacy, preservation and the security and smart electronic healthcare records. Okay. And this is with the Lausanne State University. Professor Martin is there. And Professor Monisha she is basically from the South. And now last 1 year is doing the postdoc in there. So that's why in that case that you have seen that is how federated learning and collaborative learning and these learning features, the blockchain based, and then we have applied, we got really the means better response. And IOMT means I have started my journey from telemedicine, telehealth, mHealth, eHealth, pHealth. After that, from 2017 onwards, I'm purely means actively involving in the Internet of Medical Things, basically. So in that case, IOMT, that is it increased the human-machine interaction and which enhance the real-time health monitoring and patient engagement in decision making. So connected devices that sends the vital patient-centric information in the real-time basis. And these devices equipped with the Wi-Fi for communication and Wi-Fi, this is the wireless fidelity systems. Okay, means so IEEE 2.11 wireless fidelity. That means this is the personal communication system also. That is in dot. We know that is in IEEE 11 family and 15 family. 15 family is also the personal communication. That like IEEE 2.15.1 Bluetooth, dot 3 technology, ultra wideband, dot 4. This is the Zigbee and Vibro. Okay, so many techniques are there. So mainly for improve the patient engagement and closing the patient provided communication gaps and reduction of the means your healthcare cost. And many times I've highlighted in this cost function basically, and improved and decision making and identify the patient needs and provide the tailored services. So in COVID period, we have worked with the University of Malta, and physically I have visited in the last year in few university, that one at the University of Malta, and I have seen that is AI IoT lab, very much excellent. And so that's why they are doing the excellent work. Those university having the good funds, and they're already the own setup. So the outcome is really exceptional. Okay. So IoT technology, which is the IoT for medical and health objective, like your machine learning and digitizing the healthcare systems, integrating the available healthcare resource and services, and it enhances the framework of the patient-centric healthcare, smart healthcare monitoring, providing the remote monitoring and provide the rapid emergency scenario and communicate the medical professionals all over the world. And generally, we need to decrease the expenses of the systems. Future stage of Internet of Medical Things, like is still in a nascent stage of the development. It enhances the operational efficiency and through the growing use of the network devices. And source to destination, that is many network enabled devices are there. So that means the router, if you can say the router, they are having the one capacity. If your data strength is high, then how to increase the capacity of the intermediate devices? These are the one of the tasks. And data driven decision making is likely to empower the caregivers to accurately monitor the patient comprehensive health status. So automation in healthcare monitoring is another issue. And authenticated EHR, electronic health record, health records, that is authentication, how to maintain the authentication, how to protect the data. Clear? So improves the healthcare monitoring and treatment outcomes. So these developments in sensors, objects, networks, cloud storage, computing, mobility, and big data analytics, all sectors are associated with this kind of work. And that is in the recent era, and what the lack of the IoT systems. So in that part, basically, source, you need to check the source, you need to check the communication system, you need to say the data analytics or visualization part. In communication point of view, you see that the things or objects are there. In that case, that is suppose you can say that is AI-based IoT communication system. In that case, your device to device communication. And device to gateway means this is the intermediate coordinator, you can say. Device to cloud communication, and backend data sharing model. So that's why in that case, and things are there like your sensor, actuator, and pre-processing. Then we are sending the data from local coordinator to the server. That means backend means these are the doctor enabled doctor portion is there. Mobile device means here you can develop the app. Basically, this app consists of the one is the patient centric information, another one is the doctor side information, another one is the feedback, and time to time you can get the better response from these kind of networks. A layering text structure, and we know means your 7-layer architecture. All of you are aware, like you are in the help of the OSI ISO structure, we know, and after the TCP, and this one we know that is in the 5-layer architecture, but 4-layer or 3-layer architecture is there. And specifically now the 3-layer architecture, one is the data sensing layer. Data sensing layer means we are extracting the information from the different kind of body on sensors. Okay. After that, internet layers are there, and that is the internet layer means it provides the best effort services to the users, and this data can be processed through the different kind of intermediate devices like your router, like your pointer, like your breeze, and so many things are there. Breeze, actually this is the second layer device. That means your router is there, or it operates on the network layer, or you can say maximally it can operate means also the LLC layer also. LLC means the upper layer of the data link layer, logical link control. Okay. After that, your data processing layer, in that case, your two parts. One is the supervised learning, and semi-supervised learning. Unsupervised learning is also associated with this. Another one, the data mining features. Data mining is data ontology. Okay, based on the predictive result like malaria, cholera, and this kind of data can be taken using the proper data mining systems. After that, these are the applications. Okay, so we are mainly focusing the applications, but beyond the application, we need to focus that what kind of devices we are using, what is the features, what is the characteristics. Suppose ECG, what is the characteristic, what is the amplitude, what is the bandwidth. Means these are the basic characteristics you need to learn. What kind of data, what are the data patterns, and why we are taking the means your original information, how to extract the raw information. So these are the few things you need to take care in your research domain. This is the one of the case studies, and here you see that these are the WBAN, means this is the body on sensor associated with this. In that case, that is a Wi-Fi, you can use it. This is the short term, means your short range communication technologies were involved. In the help of the short term, means short range communication technologies. So you can extracting the data from the body to your system, like your fog nodes are there. In that case, that is a fog means this is the secured node. Okay. And age fog, that means your one is the secured, another one is the efficiency point of view. In that point of view, we can use it. After that, we can process the data to the cloud. And then your different routers are there. Routers are involved. In that case, data analytics point of view, the classification, data collection, data pre-processing, data analytics, finally the predictive results, you can get it. Okay. And these IoT medical sensor devices are employed on the body of the patient, such as blood monitoring sensor, glucose monitoring sensor, to the LAN, local area networks, and the Wi-Fi, to the fog nodes, or any other means of short range communication, like a personal communication systems. You can use G.15 family, I told you. And IoT medical sensor sends the updated information in the real time for the action to the fog nodes, and fog layer contains the number of fog nodes, and it used the process of the received data. And this layer compute the biomedical data with the machine learning classification algorithms. And after that analysis, that outcome can be communicated to the end user and copy to process to the data stored in the cloud server. So, and you know that is each and every sector we are sending the patient-centric data. So each and that is one unique patient ID. That means PID name, patient identification number. Unique patient ID can be generated using the RAND function. Okay, RAND function you can use it. So randomly they are generating the patient ID. According to the patient ID, patient clinical information can be stored at the server. And if there some images are involved in that case, that is this kind of images can be processed through the medical imaging stage, like your data pre-processing, and after that means filtering, age preservation. After that, you can process the segmentations. After that, your segmentation and classification. After that, you can get the predictive results. Okay, based on the predictive result, and you can suggest by you can means inform to the patients this is the real scenario. Okay. So in that work, basically this is the temperature sensor, heart rate sensor, and blood SpO2 sensor, accelerometer, and these are the sensors involved, and we have collected the data basically. Actually, you see that is a data collection basically in the two types. One is the primary, from you can collect the data from the primary, another set of data you can collect the secondary data. So always you try to focus basically that is how to develop your benchmark database. The benchmark database is your benchmark database. That means it consists of primary and as well as your secondary data. So that's why you need to collect the samples from your real-time basis. Like you can visit the hospitals and others. After that, your literature-based data is there. After that, you can prepare your own data set. If you are having a massive, large set of the feature value or training samples, then automatically you can get the better predictive response. Okay. And here that is in this application, basically here we applied just simple the socket programming, and socket programming all of you will know. And here the input IoT medical sensor, we can use the means your input. After that, output means trigger bit and start sensor data collection. These are the IP address where you can store the data, in buffer size you need to mention. So that means this is the input and output case, and in the help of the socket programming from sensors to cloud communication, that is we can establish in the help of the socket programming case for biomedical IoT based means your health monitoring cases. Clear? So in that case, that is we have seen that is in training score, and training score means versus your cross validation score are required. That is for classification point of view, like in first one. And civic score, we got the 86% in the help of the name-based system, name-based in KNN and SVM and random forest. Random forest in the forest. Random forest is the one of the important machine learning schemes, and forest means a set of trees. Like in that case, we have used the decision trees also. So 10 decision trees we have considered that become formed as a random forest, and random forest provide the better response. It provides 96.4, and feature sample, I think that is around 9 lakh something feature samples are there. So that's why this is the model testing and accuracy for random forest around this. This is the average testing accuracies are there. So that's why in the help of the NEP-based KNN and SVM, random forest and ANN methods are there. Apart from these, that is a random forest provide the better response. So these are the details for your testing and CV score, means a validation score. We have compared and we have find out that this kind of results we got it. So based on this result, that is, we can provide the better predictive accuracy. So these are the different classifier. Classifier is involved, and that is accuracy versus recall graphical structures. So these are the one of the features, and where different kind of algorithm, different kind of classifier, where we can use and how to improve the predictive response. Clear? And this one actually basically this is the artificial intelligence and machine learning. Artificial intelligence is a technique which enables the machines to mimic the human behavior. Machine learning means this is the subset of the AI and which used for the statistical methods to enable the machines to improve the experience. And deep learning, this is the subset of machine learning to make the computation power when computation is very much effectively of the multi-layer neural net feasible. So whole of these, and this is here you can mention the data analytics. Okay, so under the data analytics, your AI, ML, and DL is there. Okay, so that's why these are the recent scenario. And recently, that is in this year, we have worked and multi-view deep learning efficient medical data management system for survival time forecasting. And this paper is published in the IEEE JVHI. And here Professor Gao is there. Actually, in this month, basically, I visited the city view in China. I spent means last month actually. So that's why I learned. I have seen that is they are having the very good means AI-based IoT deep learning based resources are there. So they are in the good funds also, and they are doing the exceptional works. So that's why. So we can learn that is how to scope and how to focus our work. These are the general slide. I think that is it will be helpful for your scenario. I believe that is all of you know, but just I am recapitulating the matters. Like one side is the algorithms, another side is the data processing tasks. KNN used for the classification, name-based used for classification, SVM classification, linear regression, and SVR mainly used for the regression model. And classification and regression trees, it is the data processing classification regression purpose and random forest, right? And k-mean use k-mean and your density based spatial clustering in the application with the noise used for the clustering system. And PCO and CCA actually means principal component analysis and canonical correlation analysis mainly used for the feature extraction. And FNNN used for the regression and classification, clustering and feature extraction purpose. And one class SVM used for the anomaly detections. Okay. So mainly the summary, this work proposed IoT-based health monitoring system where that we can get when we can collect the data from the WWAN. Okay, for heart disease prediction-based result we have discussed, and this model accuracy evaluated with the accuracy, recall precision, and specificity, and if I measure the G-mean, these are the basic parameter you need to choose in any other work also. This model compared with the previously developed healthcare models and significant improvement in the performance is observed. An IoT based health model is effective and effectively detecting the patient's heart diseases and continually monitoring their heart condition also. So that's why this work will help the doctor and who can provide the prompt treatment based the heart conditions, right? This is the another means topic. Topic means another case study, and you know that is nowadays people are working on AI, not only UI for the explainable UI, and generative AI also. So this is the one of the another paper like your here optimizing the means your 5x to GAN model we have proposed for means enable the smart health systems. And this is last year they published in Journal of IEEE in JVCI. In that case, that is that is in this work basically what this work is about. Like it focuses on the improving means your polyp segmentation in colonoscopic images, an essential task for early detection and diagnosis of colorectal cancer (CRC). That means your colorectal cancer. This is the CRC. So it uses an advanced AI systems. This is called the 5x to 5x generative adversarial networks. It enhanced with the attention mechanism. So that's why in it's the discriminator. So actually two parts. One is your generator, another one the discriminator. Encoder and decoder involved in the generator part, and discriminator is there. Because of that, we are getting means you have the better response. So attention mechanism helps the model focus on the intricate the poly features and improving the segmentation accuracy and robustness. So what is the proposed? That means your contribution is there. So in that case, your integration of standard generator and an attention-based discriminator into 5x to 5x GAN model to enhance the segmentation performance. Second, improved segmentation. This model allows to better recognition system and segment the challenging features such as the low contrast polys on the varied the appearance. Another one, the data set and training, and the model was trained on the combination of the real and synthetic data using the means your KVA search data set, and for the diverse and robust performance we have chosen. Last part is means your evaluation, and the approach was validated against the multiple baseline. Baseline mean existing mechanism like a UNet and ResNet model, also residual model actually. It's showing the improved results on key means your key metrics such as the dice similarity. Okay, and this is the means the approach, and that is a UNet, ResNet model, and other intersection over the union. These are the parameters. So main impact, and this enhanced system basically AI-driven model and can integrate into IoMT system and adding in the smart healthcare system for remote and efficient CRC detection and supporting the clinical workflow. And GAN model basically it consists of two models. One is the generator, another is the discriminator. I told you basically. And in that case, that is a C. In that, this is the proposed model. You see the ground truth images. That is after that these were the means your encoder and decoder part is there. One encoder means you can downsample. Decoder means the means rough samples are there. So all of you that finally that is after getting the output by the generator, which one the real and which one is the fake, you need to identify in the help of the proper discriminator method, in the help of the enhanced means your attention systems. And here this is the comparison results, and these results basically demonstrate the prediction generated by the baseline. Baseline mean other algorithms. We have not only highlighted our proposed model, we have already compared with the existing PyX2 by PyX model and PRANET and MSEG model, FCN and ARTNet also, and UNet and UNet model also. It shows the prediction generated for 3 input samples. Proposed method performed the best as per the diagram by illustration. So these findings suggest the potential of our model is adding the early detection and diagnosis of the CRC through automated polyp segmentation model. Okay, and parameters. And here you see that is some 6 important parameter we have considered. One is your mean dice similarity coefficient. Okay, M dice means that is into the intersection means your, and as well as your union function is there. So M dice similarity index, M dice. Another one is the MIP means intersection over the union of polyp. Another one the S measures parameter we have considered. Another one the max E measure parameters. Another one the weighted M measures and mean absolute error. So these matrices will be utilized to further validate the performance of approach and compare with the state of art techniques. So results point of view, that is in parameters and values, you need compare. So that's why here we see the final iteration. That so many iterations can involve in this work. And in that case, your values like your 5x by 5x2 and as well as your proposed model, it provides the better outcome with means compared to the 5x to 5x GAN model.
Hello, Dr. Chinmay, your voice is not audible. Dr. Chinmay? Hello, Dr. Chinmay. Your voice is not audible and no slides also.
Is it audible?
Yes, it's audible now.
Yeah, yeah. Yes, any questions from the participants?
Participants, please you can type your question in the chat.
Oh,
You can type your questions in the chat here, and then
last few slide, I think this is not visible, no? Due to link issues, I think.
the last few slides, yes, they were not visible.
Which one actually? This one, proposed model.
Yeah, this before this, I think.
This one.
Yes, yes. There is a question, Professor Chinmay. How is the data security and privacy when using AI in healthcare?
Question is that is how data security and privacy. Main point is that is what kind of data you are sending. This is the first part. Number two, that is how to extract the original patient-centric data from the raw data. Number three, you can use that is a first in the help of the encryptor and decryptor. Okay, simply data you can send it and mix up the data in between, and finally you check it that is in the help of your system that you are getting the proper response, proper reconstructed data, yes or no. Number three, security mechanism. In that case, that is a first you need to preserve your data integrity. Data means your authentication, authorization, non-repudiation. These are the factors are there. And anyhow, that is a, you need to mix up the data. And in simply, that is a KDC is there. And you can use the rand function. Randomly, you generate the beats and mix up with the series of the lines. And then end of the day, you can get the encrypted result. And these encrypted result, you can process to the communication path. And after that, you can extract from the means your server end. Okay. Suppose that is in blockchain technology. Why blockchain technology is very much secure, will provide the means better response? Because of that, blockchain means suppose source to destination, 10 nodes are there, 10 intermediate nodes are there. Each and every nodes having their own intelligent system. So that's why they are finding, if they find any kind of means arbitrary data, they can easily ignore this kind of data and process only the original information. So end of the day, you can get the better response also. So that's why in the blockchain and CPS, these are the most means your AI enabled intelligent healthcare means your security system also. So that's why based on your requirement, first you need to check, and in the help of the rand function, you need to generate the random bits. You need to mix up with the data, and each and every nodes during the communication, you need to find out that is what kind of raw data sets are involved and how to eliminate this kind of data set. Welcome. So each and every work, first you need to finalize what kind of works you are doing, what is the objective, and number two, what are the data patterns, what is the data set. Suppose you are most of the papers I have seen there, that is they are collecting and compare the data set from the Ministry Literature Survey. So better you develop your uh, the benchmark database. Main challenge is the security, the major challenge. Another challenge is that
Yes.
you need to take the your proper decision making system. So proper optimal decision making system. These are the one of the major challenges. It's one question is what are the current challenges in the AI in the healthcare sector? Just you think how to take the decision. If you don't have the proper decision in your mind, then how to progress, how to do the work. After that, suppose you have taken the one decision. After that, you need to optimal criteria you need to apply. So that's why your optimal decision making systems. Okay. After that, if you finding the optimal route, and then you can take the issues. So that's why optimality means optimal decision making system is the one issue. Another issue is that during the transmission and your data losses are there. So that's how to preserve this kind of data set. Okay, and how to preserve the bandwidth. And suppose you know that is your Shannon theorem, your capacity equal to bandwidth into log of 1 plus SNR. So capacity over bandwidth means eta. Eta means this is the bandwidth efficiency. So how to improve the bandwidth efficiency, power efficiency during the communication system. So each and everything is based on the AI. So AI challenges means one is the your data acquisition systems. AI means your optimal selection system. AI for means better visualizing system. So the means another challenges in AR/VR system mixed reality. Okay, so that's why in the data analytics and data visualization nowadays there, that is in AI having some kind of means challenges. Clear?
Thank you, Professor Chinmay, for a very good enlightening session. And now I'll ask Dr. Ravichander, are you there? Dr. Ravichander?
No, it's a good. I have seen that Professor Sengupta is there. Probably he is from Bengal, I think.
Huh? Yes?
I think you are from Bengal actually, Professor Sengupta. This title.
Yes, I'm from West Bengal.
Yeah. Same actually.
Yeah, yeah. So I like we should definitely connect after this. Sir, another question is that is AI predictive data authentic?
So what's your opinion, Nagaraju?
Huh?
You just no. Just I'm asking the means
Yes, yeah.
Nagaraju. What's your opinion? AI predictive data is authentic. You believe it? Predictive means what? Suppose one data set is there, based on the data set, based on the feature, based on the training and testing, based on the classifier, we can predict. Based on the predict, the doctor can assign but can give the medicine to the patients. So predictive results, that is a authentic, definitely the authentic, but technology can be varied. You can't say this is the 100% is accurate. It possible only you are observing the patient in visually. In that case, you can say that is suppose your telemedicine systems, telecare system. That means this is the rural communication. Really, you are just taking the patient-centric data, you are processing this data to the system. Here, that is you are applying different kind of your federated learning or any other advanced learning case in based on the classifiers. So that's why your classifier variations are there. So that's why definitely that is authentic is better. So, but with respect to the visual treatment, but this is means so long-term treatment is there. So this is the system generated information you can get. So in that case, you need to think. but it's definitely the predictive response. Because of that, nowadays in future also, people will get the better treatment modalities through the predictive data only. Is it right? What's your opinion? Exactly. Because of that, your naked eye observation, or another one, your system generated output. So that's why definitely authentic. Because of that, different vendors, they are trying to give the trustness to the patients. Okay, suppose many people they are trying. Okay, means we will visit to the CMC Vellore. Another one is okay, no, AMS Bhubaneswar is better. Another person, no, Delhi AIMS is better. So how to establish the authentic? All are very good, but trustness is required. Trustness based on your decision making system. Decision can be taken from the majority voting system, majority vote. Like if you learn about the decision tree approach, actually based on the majority vote, and then you can predict the result. So that's why authentic, it depends on the different vendors, but definitely we need to follow. Because of that, this is the long term process, and in future, that is we define the virtual mode, we can get the better treatment percentage also.
Any questions from the participants? Participants, any questions? Kesh, you can unmute all the participants. Maybe they are muted. Yes, we'll provide the slides, all the slides of resource persons and YouTube links. Everything we will provide.
I think there is no question actually.
Any questions? Okay. Rakesh, tell me. Okay. Thank you, sir. Thank you, Chinmay Chakraborty, and all the participants, those who have listened enthusiastically. I'm very much thankful to Dr. Chinmay Chakraborty for his valuable insights and introduction to health AI innovations. I congratulate once again all the participants for listening this wonderful lecture. I hope you enjoyed the session, and we will share the feedback form with you. Please fill the feedback form. And today, actually, according to the schedule, we have one more session by Steven. But due to mismatch of timings, he is from USA. He's a professor from USA. But due to mismatch of timings, this schedule rescheduled to 14th November morning, 10 a.m. So here today, this is only one session. The same schedule, the same session will be continued on 14th, 10 a.m. Once again, thank you all.
Okay, thank you, sir. Thank you, sir.
Thanks.